Hello, calculus fans. Okay, so in this section, we're going to talk about derivatives of log functions. Now, a few sections ago, we computed this, that the derivative of a to the x is equal to a to the x log a. And you'll remember that if a happens to be e being a particular number, it's about 2.718, if that happens, then you get a very nice formula. The derivative of e to the x is just e to the x. Now we're going to use this to compute the derivative of the logarithm function, and this is going to work in a very similar way to how we computed the derivative of various inverse trig functions. The logarithm is the inverse function to the exponential function, and so we can use the same method that we used before. Okay, so our problem now is to compute the derivative of log base a of x. So if we follow the same method that we've been talking about, we let y be equal to log base a of x, and then that means a to the y is equal to x. So here we're using a cancellation formula involving exponentials and logarithms. So if we differentiate this implicitly, we differentiate this equation here implicitly with respect to x, let's see what we get. So on the left-hand side, we're going to get a to the y log a. So we know that when differentiating a to the y, we get a to the y log a. But then we also have to multiply by y prime. That's from the chain rule. On the right-hand side, we just get 1 because that's the derivative of x. Now we follow the usual method. When we're using implicit differentiation, our goal is to solve for y prime. And so we'll take this equation, and our goal is to solve for y prime. And so that's how we'll get that y prime is equal to 1 over a to the y log a. And now here's the key step. This a to the y turns into x because we have this equation here. That's what a to the y is equal to. So that gives us a formula for the derivative of log base a of x. Notice that if a happens to be equal to e, then we get a nice formula for the derivative of the natural log function. And this is going to be an analog to the nice derivative formula for the natural exponential function. So we'll be able to write it like this. We'll say that the derivative of log of x, the natural log of x, is equal to 1 over x. I'd like to point out that this is the reason why we need our bases of the exponential and logarithm functions to be e. Those functions have very nice derivatives. And now let's summarize all these that we have collected. I think you're going to want to remember all 4 of these differentiation formulas. The derivative of a to the x, the special case of e to the x, the derivative of log base a of x, and the special case of log x. Notice that these 2 are the nice ones. When you use the natural base, you get nice differentiation formulas. This is similar to the nice differentiation formulas that we got with sine and cosine because we used radian measure. So these differentiation formulas in calculus are a little bit particular. You have to use the right setup to get the nice formulas. For exponentials and logs, you want to use a natural base. For trig functions, you want to use radian measure for your angle. Okay, that's all for now.